Video, we're going to talk about the ratio test. The ratio test is a fundamental tool for determining if a series converges. So here's how it works. You start with a series, and the series is going to have terms, and we're going to say that the terms of the series are a sub k. So it's k sub 0 to infinity a sub k. Then what we're going to look at is the ratio of basically the ratio of the next term to the current term. So we're going to look at the limits as k approaches infinity of the absolute value of a sub k plus 1 all over a sub k. This will give us a number or infinity. So we're going to find the value of this. And then what we look at is what happens here. So if the value of this limit is strictly less than 1, including 0, then the original series that we were looking at, we know for sure that it converges. The limit of that expression, that ratio of coefficients, is strictly greater than 1, then we know that that series diverges. And there's one more case, which we haven't looked at, which is what if it's equal to 1? Both of these cases, you get a definitive conclusion. Well, let's just go ahead and say before we do either of those, that if that limit is equal to 1, you can draw no conclusion. You should use a different test. So now let's ask ourselves, does the sum from k equals 0 to infinity of 4 to the k over k factorial converge or diverge? Well, we can look at our a sub k here. Our a sub k is 4 to the k over k factorial. We can look at our a sub k plus 1, which comes from just taking k in our original argument and replacing it with k plus 1. So a sub k plus 1 would be equal to 4 to the k plus 1 over k plus 1 factorial. When we look at applying our test now, we're going to be looking at a limit as k approaches infinity, 4 to the k plus 1 over k plus 1 factorial, all over 4 to the k over. Now we're going to use our algebra for dividing fractions, and we're going to have 4 to the k plus 1 over k plus 1 factorial times k factorial over 4 to the k. It's really important when we see this k factorial and this k plus 1 factorial that we know that we can cancel. So we're going to have the limit as k approaches infinity of 4 to the k plus 1 over k plus 1, k times k minus 1, 3 times 2 times 1, times, and up here on the k factorial, we have k times k minus 1 times 3 times 2 times 1. So all of these things are going to cancel, except for this k plus 1. Similarly, when I look at 4 to the k plus 1 times 4 to the k, that cancels as well. This 4 to the k cancels with this 4 to the k. And I'm left with the limit as k approaches infinity, 4 over k plus 1. Now look what's happening. The numerator is staying fixed at a constant value. The denominator k plus 1 is going to infinity. So this is equal to 0. I'm not done. I've done an important step. There's one more thing I need to do. The final step is I need to interpret what I got from calculating the limit. So this limit is equal to 0, which is certainly less than 1. So because the limit as k approaches infinity, the absolute value of a sub k plus 1 over the absolute value of k is 0, which is less than 1, we can conclude that the series, the sum from k equals 0 to infinity, 4 to the k over k factorial converges. So we have our final answer of converges by applying the ratio tests. Okay, so does the sum from k equals 0 to infinity of k over 3 to the k converge or diverge? And even though there might be other tools I could use, I'm going to use the ratio tests. So I'm going to write out my a sub k, which is equal to k over 3 to the k. And then I'm going to write out my a sub k plus 1, which is k plus 1 over 3 to the k plus 1. So I've established my terms here. After I've established my terms, now I'm going to look for the limit as k approaches infinity of the absolute value of a sub k plus 1 over the absolute value of a sub k, which will be the limit as k approaches infinity of k plus 1 over 3 to the k plus 1 all over k over 3 to the k. Now I'm going to use my algebra of fractions here, my keep change flip trick. I have the limit as k approaches infinity, k plus 1 over 3 to the k plus 1 times 3 to the k over k. Remember, I can flip this fraction and multiply when I'm doing this division. Now there's nothing that cancels between the k plus 1 and the k, but there is something that can cancel between the 3 to the k plus 1 and the 3 to the k. So this will be the limit as k approaches infinity of k plus 1 over k times 3 to the k cancels with 3 to the k, and I'm just left with 1 over 3. Now I'm not done because I still have these k terms, but the limit as k approaches infinity of k plus 1 over k is equal to 1. So the 1 times 1/3 is just equal to, so I could pull this 1/3 out front if I'm being careful. I'm going to have the limit as k approaches infinity of k plus 1 over k, which is just equal to 1. You can know that as a basic property, or you get there by L'Hopital, but this is equal to 1/3 times 1, which is 1/3. So at the end of the day, what I've determined is that when I take the limit of the, as k goes to infinity, of the ratio of the absolute value of my coefficients, that in this case, the answer is 1/3. So now what's left is to interpret. So I'm going to interpret what I can conclude from looking at this, which is that series k equals 0 to infinity of k over 3 to the converges by the ratio test. Because the ratio test says that if the limit of the ratio of the absolute value of the coefficients is less than 1, then you have the conclusion that the sum from k equals 0 to infinity of k over 3 to the k converges. It's not always good to use the ratio test, even though it is really powerful. There are situations where it just doesn't apply. I'm going to show one where the ratio test doesn't give us the information that we might hope for. And this is important because sometimes people just fall in love with the ratio test and try to use it for everything. But we've learned a lot of other really cool tests that are important to use. So let's look at it. Let's be sure we don't forget them. First, I'm going to apply the ratio test just to see what happens. So I look at the limit as k approaches infinity, the absolute value of a sub k plus 1 over the absolute value of a sub k, which in this case will be the limit as k approaches infinity of the square root of k plus 1 over the square root of k, is equal to the limit as k approaches infinity of the square root of k plus 1 over k, which is equal to the limit as k approaches infinity, which is equal to the square root of the limit as k approaches infinity of k plus 1 over k. Limits do work this way with continuous functions. Well, this is just 1, so this is the square root of 1, just 1. Now remember, that means the ratio test is inconclusive, because we're on that boundary case where this limit is equal to 1, we cannot make any conclusions. And actually, it was really silly to use the ratio test, because we could have just done this with the test for divergence. The limit as k approaches infinity of the square root of k is equal to infinity, not 0. So it's much easier to see that this series diverges just by looking at the fact that the coefficients don't go to 0. Let's look at one more example. Let's look at the sum from k equals 1 to infinity of k factorial over k squared. And let's ask, does this converge or diverge? So when we look at this, if we're going to use the ratio test, which seems like a reasonable thing to do, we're going to be looking at limit as k approaches infinity of k plus 1 factorial over plus 1 squared times 4 to the k plus 1 all over k factorial over k squared times 4 to the k. And then we're going to rewrite this as the limit as k approaches infinity of k plus 1 factorial all over k plus 1 squared times 4 to the k plus 1 times k squared times 4 to the k all over k factorial. Now, I have a little bit of rewriting here. I'd like to rewrite this so that the ratio of terms that makes sense to go together, I can do that. So I have k plus 1 factorial over k factorial times k squared over k plus 1 squared times 4 to the k over 4 to the k plus 1. Now, I can do some cancellation here. This is going to be equal to limit as k approaches infinity of k plus 1 over 4 times limit as k approaches infinity, k squared over k plus 1 squared. Now this limit is equal to 1, And this limit is equal to infinity, because as k plus 1 gets bigger and bigger, dividing it by 4 does nothing to slow down or doesn't do enough to slow down its march to infinity. So I can think of this as infinity times 1. The final answer would be infinity. Now, infinity is bigger than 1, so we can conclude that because this ratio is bigger than 1, that the original series diverges.